This video shows how to create, build, and debug a Smart Configurator project for Renesas RISC-V device family on Visual Studio Code. Smart Configurator is a code generation tool for RISC-V MCUs. It offers support to generate Smart Configurator projects directly to the Visual Studio Code environment. This can be achieved in a few quick steps. Before you start, make sure to have Smart Configurator and Visual Studio Code with Renesas Debug extensions installed. Navigate to the links provided in this video to download and install the necessary installers. After installation, launch Visual Studio Code and open the command palette. Select the Renesas Support Files Manager and install RISC-V MCU family-related support files. Add the installed compiler path to the environment variables. The main part of this video can be divided into 4 sections. How to create a Smart Configurator project in Visual Studio Code. How to configure the project and generate C-source and project files. How to build the project. And finally, how to debug the project. Open the Visual Studio Code application and launch the command palette. Enter Renesas, create RISC-V MCU project with Smart Configurator until the option appears in the drop-down list. Click on this option. If you have not launched Smart Configurator from Visual Studio Code before, you will be prompted to provide the location of the installation. Click on the Browse button and provide the path to smartconfigurator.exe. Next, you will be prompted to provide a folder location for the project. Click on Select Folder to confirm the project path. Once done, Smart Configurator will launch automatically. After Smart Configurator is launched, select the device part number and toolchain from the dialog box. This demonstration uses FPV board and LLVM for RISC-V toolchain as an example. Next, provide a project name and then click Next. Choose a project template. This demonstration uses bare metal, Blinky as an example. Then click Finish to complete the project creation steps. The project is created successfully when the Smart Configurator editor is launched. The second part of the video will walk you through the steps to configure and generate the source files for the Smart Configurator project. Configure the project, including the MCU clock, pins, and interrupts, by clicking on the tabs at the bottom of the editor. Software drivers and middleware can be added from the Components tab. Once you are satisfied with the configurations, click on the Generate Code button. The third section of the video will walk you through the steps to build the project in Visual Studio Code. Switch back to the Visual Studio Code application. Build the project using the shortcut key Ctrl+Shift+B and selecting the option to build project. Wait for the build to complete and check the results from the terminal panel. The final section of the video will walk you through the steps to debug the project in Visual Studio Code. Connect the RISC-V target board to the PC via a USB Type-C cable. To prepare for the debug session, open Launch.json file from the project and fill in debugger type. Additional parameters might be needed depending on the board that you use. Start the debug session by selecting the debug configuration. Click the Start Debugging button in the Run and Debug view or press F5, then select the executable file. A debug session will start. Basic debug control flow functions like suspend, resume, step into, step over, step out, restart, terminate debug session can be performed. Display of variables, watch expression, and call stack are also supported. For more information on CMake, the related toolchain and debug configuration settings, navigate to the provided link.